By now, you've seen some of the power of promises. As your code transitioned from being nested function inside of nested function to chains of thens and catches. To truly get the power of promises, though, you need to be able to create your own promises and not just use them from other libraries. As you think through consuming promises and you start to think about what you'll need to do to create your own, what are the major aspects you need to consider? You need to consider the three states and how you'll manage them: pending, fulfilled, and rejected. Pending is probably the easiest state to handle, because remember, a pending promise is just a promise that's not yet settled. When you create a promise, it's pending until you tell it to move to the fulfilled state or the rejected state. This leads to the question of how do you create a promise? Before we answer that, let's look again at the definition we saw earlier in the course. A promise is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. We've already talked about eventual completion and we've talked about asynchronous operation. But do you see anything in the definition that tells us how to create it? Well, it starts with the first word. A promise is an object. And this is an example of how you could create one, just like you would create any other object in JavaScript. At this point, temp is a pending promise. So now that you know that, how do you make it change states? Since we're in the Creating Promises module, let's open the creating.mjs file just like we did in the past. And we'll start with our first function. In this case, it's timeout. We want to take the asynchronous function, setTimeout, that we saw at the end of the last module, and turn it into a promise so we can take advantage of all of the benefits of promises. Let's take the code we just saw in creating a new promise and use it here, but this time let's call our variable wait. Our promise is now in the pending state. We're eventually going to have it switch to the fulfilled state, so let's handle that situation now. Now that we have that out of the way, we need to figure out how to make a promise change states. The first thing to know is that a promise takes a function as the one and only parameter to its constructor. This function is called the executor function. So update the line that creates a promise and pass in an empty function as the executor. Next, let's put our setTimeout inside that executor function. Since, as we've seen, promises are eager, this code will start to be executed immediately, which means our empty function will be called 1500 milliseconds after we new up the promise. But the function running doesn't change the state. The executor function does take a parameter, resolve. This parameter is a function that the promise can use to call and resolve its state. So let's add that in now. Now we need to call our resolve state when we're ready for the promise to be fulfilled. So let's add resolve to the anonymous function inside of setTimeout. And let's pass the string timeout to the resolve function. This will be our return value. We now have a promise that we'll call resolve, which will set the state to fulfilled, and then call our then function. Let's see all of this in action. If your server's not running, make sure you run the command npm run dev before you head over to your browser. Once you're in your browser, navigate to localhost 3000/home and then choose the Creating Promises link. Click on the Timeout link. After 1.5 seconds, the result box updates to show our timeout text. Our then function got called one time, and only one time. But then again, the setTimeout function will only fire once, after 1500 milliseconds. In the next clip, you'll see a key illustration that will help demonstrate promise states using a function that will update multiple times. What happens when a function that's been promisified fires multiple times? Understanding this will help you understand promise states. Let's go back to our creating.mjs file. Start by copying code from the timeout function into the interval function. Next, replace the setTimeout function with setInterval. setTimeout and setInterval are very similar. The main difference is that setTimeout will only call its internal function one time when the timer expires, but setInterval will call multiple times, once every time the timer expires. In our case, that's once every 1.5 seconds. To see this in action, let's create a counter outside of setInterval and update it inside of our function. Then let's add a console statement so that we can see every time this function fires. After we write that code, let's jump back to the browser. As always, reload the web page to bring in the new code, and then click on the interval button. After the first 1.5 seconds, you'll see the response box update to timeout1 and interval logged out to the console. After the second 1.5 seconds, the result box still says timeout1, but a second interval is logged out to the console. In fact, no matter how long we sit and wait, our results never update past timeout1. But at the same time, you can see that the interval count keeps rising. So we know our internal function has been called. So what's going on here? To answer that, hop back into the code. Let's add a finally block at the end of our then statement. Before we return to the web, what do you think the counter will be in finally? Once you have your answer, go back to the browser and refresh the page, and then once again click on the interval button. Once again, the result box shows timeout1. This time, though, it appended that done1. So does showing done1 shed any light into what's going on? Remember earlier in the course when we talked about states? I mentioned that there are two other words that are used to reference when a promise is no longer pending. Those words are settled or resolved. Based on the last demo, you can see that once a promise is settled, its state is not updated. That's because if the associated promise has already been resolved, either to a value, a rejection, or another promise, this method, the resolve method, does nothing. That is, once the promise is settled, it's done, and attempting to settle it again will have no effect. It's also why the finally function in our last demo had the counter as 1. The function itself continues to run, but the promise will not change. So how can we make the interval stop? Go back into your code and copy the interval code into the clearInterval chain function. After we do that, we need to make a couple tweaks. First, before the promise is created, create a variable named interval. Next, assign the return value of setInterval to the new interval value. Lastly, inside that finally block, call clearInterval and pass in your new interval value. This will stop the interval. Returning to the web and reloading the page, you can click the clearInterval button. As before, you can see the timeout1 in the results box after about 1.5 seconds. You can also see the interval logged out to the console. But if you wait there, you won't see another interval logged out, because in our finally block, we cleared the interval. It's another example of using the finally function to clean up after a promise. If moving a promise to the fulfilled state is that easy, then surely moving it to the rejected state is just as easy, right? Well, we'll find out in our next clip. The previous two examples were overly simplified. It's not that resolving is more difficult than what you saw, but those two promises don't have a way to set the promise to the rejected state. You'll see how to do that now. Let's head back to the creating.mjs file and go to the XHR function. In this function, we're going to make an XHR call, similar to what we did earlier in the course. But this time, we're going to put it inside of a promise. As we saw earlier, XHRs have an onLoad function for successful calls. And since it's the success call, that's where we want to fulfill our promise. So let's add our resolve to the promise executor function and then call resolve for onLoad. At this point, we're right back to where we were with the previous examples. We created a promise and then set it to the fulfilled state when something happened. Next, we need to handle the case when something goes wrong. In our case, it's going to be a 404 because user ID 7 doesn't exist in the Carved Rock Fitness API. We know that there is an onError function, but how can we use the onError function to change the state? What if I told you that the executor function took a second parameter? That second parameter is the reject function, so let's add that. Now all we need to do is provide a then and catch function for our request promise. With that, hop on over to the browser. Reload the page and then click on the XHR button. The response shows an empty object, but it doesn't say request failed. So that means our promise wasn't rejected. Go back to the code and look at the XHR code. The problem is not with the reject function. The problem is that XHR only calls onError when there's something like a network error and the request failed to be completed. All other calls wind up in the onLoad function. So let's tweak that to check for XHR status. Now return to the browser and reload. Once again, click the XHR button. This time, the result shows up as not found because that was the response from the server. This shows that you have the power to control when your promise is fulfilled or rejected. The code we just wrote had multiple reject statements. That's because there were multiple reasons why the call could fail. You could also have multiple resolve calls if they're in different paths. You've already seen how to call a single promise, or even how to call a second promise after the first promise has settled. In the next clip, I'll show you one function that will let you queue up several promises at once, and then wait for them all to be fulfilled before continuing on. Have you ever needed several functions to run, independent of each other, but you couldn't continue until they were all complete? If so, that's a use case that promises excel at. One of the first large-scale applications I wrote using JavaScript required a lot of metadata. There were users and customers and jobs and accounts, and each of those had their own statuses and types and other pieces of metadata. We might have needed 10 pieces of metadata to perform one single action. But I didn't need to load the user metadata and then load account metadata because the data wasn't really related. I just needed to make sure that all of the metadata I did need was loaded before I continued. In fact, not only did I not need to have sequential API calls, I didn't even want them. That would have been too slow. I wanted to batch up all of my calls, fire them off all at once, and then move on once they all came back. This is part of the power of asynchronous programming. You don't have to wait for one call to finish before you can start another. And with promises, you can still tell the code to not continue until all of the data comes back. Our code in this clip is going to load all of the metadata from the API. Specifically, that's item categories, order statuses, and user types. Return to the IDE and the creating file once again. Navigate down to the all promises function, as this is where we'll be spending our time in this clip. Since we're loading data from an API, let's use Axios again. Now remember, Axios is built using promises, so each of our variables here is a promise. The question is, how can we wait until all three of these promises are fulfilled, particularly when we don't know the order that the API will return them in, and in reality, that order might change from call to call, depending on the API's load and other considerations. Since we want all of the promises to be fulfilled, we should use the all function on a promise. To do this, we do not need to create a new promise object. Instead, we call promise.all. And then we pass in the three variables that we just created. This will queue up all three promises and wait until all three return. we can attach a .then function to this all function so that we can handle it in the same way as before. But what will be the result value in the then function? Do you have any ideas? It's going to be an array of results, and the order will match the order that we added them, not the order that they were resolved. And that's good news because it means categories will always be the first result. Remember that these are Axios objects coming back. Therefore, we need to access the data property on them to see our data. Hopping over to the web, if we reload our page and click on the All button, after about 1.5 seconds, we see a list of data dumped out. As we scroll, we can see that includes item categories like kayak, and order statuses like shipped, and user types like individual. And if you look at the console, you can see that all 3 calls were made to the API. And even though the first 2 responded nearly instantly, the call waited until the order status call completed. Remember, this call has a 1.5 second delay in the API. What happens though if one of our calls fails? Will it sit there waiting endlessly for it to be fulfilled? Well, let's tweak our code and find out. Start by adding a 4th Axios call. Then add it to the promise array. And of course, add it to the then as well. With that, hop back to the browser. Refresh and rerun the all command again. This time, nothing is updated and we have an error in our console. Do you remember what we have to do when we have an uncaught in promise error? That's right, we've got to catch it. So add a catch statement after the then. Save this and head back to the browser. Reload and rerun that all function one more time. Notice what happens. Not only does the box update nearly instantly with a 404 error, but if you noticed in the console window, it updated before the order status call even completed. Let's rerun that and pay attention to the console. The all function will wait until either all promises are fulfilled or until the first promise is rejected. This can be useful in a situation where you don't want to continue if any of your promises are rejected. For example, if the address types data had been something so essential that we couldn't possibly continue without it, we wouldn't want to wait for other promises to complete before continuing on. But what if that's not the situation? What if the data is so independent that you don't really care if 1 or 2 calls failed, and you still want to wait until they're all settled? I'll show you the 2 things you need to change to make that happen next. Sometimes when you queue up promises, you want as much data as possible to come back. If 1 or maybe even 2 promises fail, that's okay, so long as you get the rest of the data. To see how to do this, open up that creating.mjs file and modify the code for the allSettled function. Start by copying the code from the previous clip, the all function, into this function. The first thing to change is the name. Instead of all, it's allSettled. allSettled is similar to all, but it's different enough that I want to pop out to some slides to explain it before we use it. First, the data that's passed back is different. All returns the results object as part of an array, but allSettled returns a different shape. It has 2 keys. The status key will be either fulfilled or rejected. And then the second key will be either value, if the status is fulfilled, or reason, if the status is rejected. That is, the then function on allSettled will return all promises, even if they were rejected. Which leads to a second difference. We don't need a catch block because this promise will resolve with an array of data, including rejected promises. Even though a catch block is not specifically needed, it's still a good practice to include. It will help catch any errors that might occur inside of your then block, for example. With that very brief explanation, let's hop back to the code and take a look at what this would look like. Start by changing what's received in the then function. Instead of individual values, simply pass in a values parameter. Next, let's add some code to show what the status is and a glimpse of the data we get back. And to do that, we can delete all of the body of the then function. This code, first of all, checks the status, and it checks to see if it's fulfilled. If it is fulfilled, then it constructs a string that includes the data that was passed back. And in this case, it's only taking the first element of that array. If it was not fulfilled, it'll set the status to rejected and give the reason why. And notice with both of these strings, there's an empty space at the end, and that'll just help for formatting on a smaller screen. Reload the website in your browser and click the allSettled button. The results in the window appear after 1.5 seconds, even though the address types call rejected nearly instantly. The data shows the first 3 promises were all fulfilled, and the last one was rejected with a 404. By changing the name of the function from all to allSettled, and by expecting a different object shape in the then function, you're able to queue up several promises that wait until they're all settled before calling the then function. One thing to note here, as of the time of this recording, not all browsers support allSettled. The ones that do are primarily Chrome and Firefox. To check the status, check out the MDN page listed on the screen. In the next clip, I'll show you how you can use promises to get data from the fastest API endpoint and ignore all the other data. Earlier in the course, we saw how race conditions can cause problems. But with promises, we can actually use them for our advantage. Imagine that you've got a few copies of your endpoint deployed, perhaps in some geographically diverse locations. The time to get data from these various endpoints can vary based on where the request is coming from. What you'd really like is to get the data from the endpoint that is fastest for you. You don't care which endpoint that is, so long as it's fast. Promises can help simplify this. Your default instance of the API is already running on localhost 3000. But from your terminal, run the command npm run secondary. This time you see that the server is now running on localhost 3001. In fact, by running both the dev and secondary commands, you have 2 instances of your API running. Let's use these instances to see how promises can help with the data. Inside your creating.mjs file, jump into the function named race. Start by creating 2 requests. The first one will get the list of users. The second request is also to get the list of users, but this time it's a different endpoint. It's localhost 3001. The next step is to fire off both of these requests, but we want the results of the first one to settle. So we won't use all or allSettled because those would wait for both of them to settle. Instead, we'll use promise.race. Next, we need to add a then function. This will return with the first promise to settle, so will only be a single value. Finally, we need to add a catch handler. As long as you have both the dev and secondary endpoints running, head over to your browser and reload the page. Click on the Race button. When you click this, the data almost immediately comes back and it shows up in the results pane. And if you look at the console, you can see both requests were fulfilled and that in my case, the localhost 3000 request was faster. But the point is, for this case, it doesn't matter which one came back faster since they're duplicate endpoints. One important note here, race will return whenever the first promise settles. If it settles with a rejection, that will call the catch function and you won't get your data. Since race will take the response of the fastest promise, it's not going to have a lot of use cases. Most of the time when I'm queuing up promises, I will use all because I want to use the data once all my promises are fulfilled. but you should still be aware of the race function, even if it's rarely used. Earlier, you learned about consuming promises. In this module, you learned how you could create your own promises, and hopefully you learned that creating them isn't too scary. You create a new promise with a basic constructor. Then you pass in an executor function with a resolve and reject parameter. You can use these parameters to set the state of your promise to either fulfilled or rejected. And you're in complete control of when each state should be set. You even learn that there's 3 distinct ways to queue up a list of promises. All will wait until either all promises are fulfilled or until one promise is rejected. allSettled will wait until all promises are settled, either fulfilled or rejected, but it's not supported in every browser. Race will only wait until the fastest promise is settled. With these functions, you have a lot of control over how promises are used in your application. A few years after promises were developed in JavaScript, the language came up with async await. And I think now that you know the basics of promises, you're ready to learn some secrets about async await. The next module will help demystify this operator. And once you understand one important fact about async await, your knowledge of promises will transfer to this new syntax as well.